on retrouve le Colegiul national Emil Racovita de Cluj en Roumanie, qui vont nous parler de maths et Légo. Alors, je vous rappelle que ce lycée, si vous avez déjà suivi quelques sessions de ce congrès, est jumelé dans le cadre du projet Erasmus+, maths et langage, avec le lycée Val-de-Durance de Pertuis, et ils ont travaillé sur ce sujet avec des élèves du lycée qui sont indiqués sur la diapositive, comme vous voyez. Et donc là, c'est Anka, Vlad et Tudor qui vont nous parler de tout ça. Ils vont nous parler en anglais. So Anka, Vlad, Roman, you can go. You can begin your talk.
Bonjour, my name is Anka Dan.
Hello, I'm Roman Tudor.
And I'm Revnik Vlad. You are all students at Colegiul Național Emil Racovita from Cluj-Napoca.
Before we begin our presentation, we have to say that this will be held entirely in English as we are not studying French at school.
During this year, we chose to research topic number 1, which says that on a Lego plate, we put 2 small pieces of 1 by 1 randomly. And the question is if we can always connect them with a Lego bar piece of width 1. To begin, I would like to tell you why we decided to approach this research topic. We especially liked its possibility of using practical methods and the fascinating mathematical systems found in Lego brick combinations.
Also, we would like to clarify some notions about the Lego vocabulary we used throughout our presentation. As you can see in the left chart, we have the names of each individual part. We have bricks, plates, tile, studs. The only difference between a tile and a plate is that a tile has no stud. A stud is the circle on top of a brick, which helps realize the connection between the Legos. Also, on the right image, we can see an official Lego chart with the dimensions of a 1 by 2 brick, which was very helpful throughout our presentation to convert bricks into units.
Now, what is a unit? A unit is equal to the length of a brick, number of studs, minus 1, because we consider that the connections are realized in the middle of the studs. So in both ends, we have 2 halves that won't take place in the actual connection. So a brick of 6 studs is actually a brick of 5 units. When we approached the problem, we found 2 possible methods. The first one is triangle method, where we consider that the hypotenuse of the right-angled triangle is the brick that connects the 2 randomly placed bricks. After creating the actual triangle, we use Pythagoras theorem in order to find the length of the hypotenuse. The second method is the circle method, in which we consider one of the bricks the center of a circle, and the second brick a point moving on the circle. In this method, we will always have 4 perfect joints that are also placed on the axis here. Due to the fact that we can't create a perfectly shaped circle on a Lego board, we can't be sure that on each sector we will have perfect joints. For example, here it looks like we will have a perfect joint here or here where the circle meets the center of a brick. I would also like to mention that recently we thought about the fact that we can put the axis, the perpendicular axis in other position than horizontal and vertical. So we didn't have enough time to actually see what would happen in that case.
Okay, so now I'll explain you how to get to perfect cases or ideal cases. What is a perfect case? That when we connect 2 pieces, there's no tension between them. In order to connect 2 random pieces on the board, the length between them must be a natural number of units. This is because Lego bricks have predetermined values, as my colleague has shown you in the chart above. The first way to get an ideal case is by using Pythagoras theorem, which we all know. It's side 1 squared plus side 2 squared equals hypotenuse squared. Now, keep in mind that this only works when the hypotenuse is of 5 units or more. This is because the smallest Pythagorean numbers are 3, 4, and 5. When we're talking about smaller pieces, so pieces smaller than 5 units, we'll actually have to use axes in order to connect them. So, if I consider this stud as being the middle of the axis, and I put a brick in it, and then I put a brick here, and let's say there's a length of 3 units between them, we have no problem connecting them at all. Now, keep in mind that even if this method is the only one applicable to pieces smaller than 5 units, we can apply it to pieces bigger than 5 units with no problem at all. So again, if I consider this stud as being the center of the axis, and I put a piece here, and the length between them is 14, 15, 18, it doesn't matter how many units, we can perfectly connect them. And the last way to get a perfect case is by using the circle method. Now, again, if I consider this stud as being the center of a circle, and I put a plate on it and consider it the radius on the circle, and the plate is moving like this, describing the circle itself, I will get perfect joints where the end of the plate overlays perfectly over the center of the stud. In other cases, we will get joints with errors, which my colleagues is going to present.
And this brings us to the error cases. So what is an error? Firstly, we have to keep in mind that due to the low flexibility of Lego bricks, but yet an existent one, in some very particular cases, it would be possible to realize a connection between two Lego bricks, even though the length between them is smaller or greater than the connecting plate itself. Most of the time, the difference will be only a few millimeters or a fraction of a millimeter, so the error itself is not possible to be seen with the naked eye. Thus, when an error case is created, we will have an angle between the brick and the base plate, which we defined as an error angle. This kind of error angle can be very easily spotted by just simply touching the connecting plate itself. If we feel that the bricks develop tension, that means we are in a connecting issue or an error. Also, through experimenting and the use of trigonometry, we determined that the maximum angle of error has a value of 20 degrees, 15 minutes, and 56 seconds. This kind of error is only achieved when the brick meets the connecting plate right in its corner. In this picture right here, we can see a representation of the maximum angle of error, in which the angle is alpha. The angle of error can be easily calculated using the formula tan of x over y, and in this case, x is equal to the length from the center top of the stud, which is right here, to the point in which the brick meets the connecting plate. In the maximum error case, that point will be right in the corner. Y is the height from the center top of the brick, which would be here, again to the very top of the stud. And using the formula, we determine that the value is 20 degrees. And now to the conclusions. We found out that the easiest way to solve this problem is by using Pythagoras theorem, and that is because, as my colleague said previously, Lego plates have a determined dimension. Thus, a connection will be only realized if the length between the two Lego pieces is at least of 5 units. An ideal case. The length will have to always be a Pythagorean number because, as we said, plates have a determined number of studs. It can also be a multiple of a Pythagorean number. these are the sources that we use. And thank you very much for your attention.
We thank you very much for what we hear from you. It's a beautiful talk. And we have some questions about that. Everybody is very happy with your talk, but they have some questions. The first one is, putting ourselves in a theoretical case, can we find the points of the circle?
In a theoretical case, the points in which the circle will meet the brick itself has to be calculated using, again, Pythagoras theorem, or by simply using it as an experiment. So we choose, like my colleague showed you in the chart, a brick, which will be the center, and then we will move a plate alongside the circle's circumference. And if the plate overlays perfectly on top of the brick that we wish to connect, then we will be able to find the connection itself.
Thank you. There's another question. Does the flexibility of Lego bricks increase by far the number of reachable length?
Yes, if the length is bigger than 6 studs, the flexibility will be way bigger. But it's very low, so we have to keep in mind that it's a very low flexibility, and it affects the joint between the bricks only with a fraction of a millimeter, so we as humans cannot detect that kind of error.
Yeah, thank you.
It's negligible.
And we have questions still. Can the number of bricks that fall exactly on a circle be arbitrarily large when the radius is allowed to be large?
Well, theoretically it can be, but we'll have to use a big plate. We are talking about a piece with 100 of studs to get a large number of bricks that fall exactly on the circle.
Okay. And are all the red dots good on the picture here? I think it's
On the picture with the circle method?
yeah.
No, not all the red dots are perfect connections. We use all the red dots in order to, let's say, create the form of a circle. Not all the dots are good connections.
Okay.
We built the picture like that in order to show the trajectory that the plate will move. And now, if you would like, we can show you the correct combinations on the plate. Just 1 second. Okay, so the correct combinations are only in the places in which the circumference of the circle overlays perfectly. For this case, we have a plate of 32 studs long, which is 31 units. And we found out that we have at least 3 cases, one being right here, if you can see it.
Yeah.
One somewhat in the middle at 45 degrees or so, and another one which is the symmetric to the first one right here.
Okay.
So 3 perfect joints. The other possible ones will be an error joint.
Okay. Yeah, there is a question. Do you mean that if there is a plate you can place between a center and the point of the circle, the radius is a Pythagorean number? Did you say that? I don't know. Did you think about that?
If the radius is a Pythagorean number, it's just like using the triangle method. I think we forgot to mention that these 2 methods, the triangle method and circle method, they can be used together as one. There are 2 interpretations of, let's say, a bigger method. So to show you, if we go to the slide with the circle, one second, right here. If the radius is a Pythagorean number, we can just, so let's say the connection will be here, yes? We can draw the projection of that point on the OX, and we have a Pythagorean triangle. So the triangle method is most likely an extension of the circle method.
Okay. Thank you. If you allow a length that is slightly different from an integer, as you mentioned it, is it possible to place a tile in any direction?
Theoretically, there is no tile that is not an integer number. All Legos have a predetermined dimension, as we showed you. So let me go to the chart, because there are the official Lego dimensions.
Yes.
1 second, please.
Yeah.
So as you can see, a 2x1 plate or brick, no matter if it's a tile, brick, or a plate, it has a width of 8 millimeters and a length of 16.
Yeah.
So there are no plates that are not an integer number. All plates are a multiple of 8 millimeters. The smallest possible, let's say, dimension is 8 by 8 millimeters if we have a 1x1 brick, the white one right here.
Okay, you didn't study not very well made Lego books. Which way? Okay. I think that there's just one question more. If 1 point is good, I think it's in the case where is double is good. I don't understand what is double. Maybe Hubert could explain that, but if not, double 1 point is.
This question is for the circle method.
Yeah, I think it's for the circle method.
Yes, in the circle, yes, because it's the same thing. So let's go back to the
circle, yes.
Circle drawing, yes. If this one is good, also it's symmetrical will be good, because it's the same way looking at the circle. It's just that we look from this direction instead from this direction.
The symmetrical point.
That's the symmetric of the point itself.
Thank you very much for your explanation, and you answered very brightly to the questions. I hope that everybody understood my English. I'm sorry for it, and I hope we'll see you back very soon. I thought you already wrote an article, I think, or if you didn't, I hope we'll receive one from you.
We are working on the article.
Thank you.
It's in their work.
So thank you once more. Everybody is congratulating you, and I hope we see you next year in our 1 hour congress.